Hello and good day to all my fellow marine engineers, naval architects, all those in the shipbuilding sector, the seafarer fraternity. About 2 months ago, I had this opportunity to talk to the cadets at IMU Kolkata, the Mary DMET. We got this idea that there has to be some kind of an interaction between the alumni of our marine engineering and other seafarer institutes, as the shipping industry is undergoing through vast changes, as is every other field in this world. We are having developments that we never saw in my younger days, and the kind of challenges that are the future marine engineers are going to face are going to be humongous, a little tight, and will need a little more than general knowledge from the books and the courses that the institutes are giving them. Of course, the institutes are doing a wonderful job, and when I was at the IMU, I saw that all the course curriculum and everything has been tuned to what the future is bringing. I even saw books and actual studies being conducted on subjects that were not entirely what we call life at sea or marine engineering as we know it. They're going into a lot of other things, into UPSC and into the examinations in some other fields of work, and also in the business administration and in studies for the MBA. I think all that is wonderful, but I think this pool of expertise and experience that we have in the alumni who are working, some at ships, some in the shipyards, some in the shipping companies, and some not even in the shipping jobs as such, like me. I have been in the power and the electricity sector, and mostly into the making of the power projects. And I do music, and that's why I'm starting this course, because I have this access to this wonderful studio, which I have kind of put up over the last 10 to 12 years. And so we have this means of communication, and I think it's what the people at sea always have needed is the modes of communication that are clear. We have come out of those days when many know the story also, where a chief engineer had to write a letter on the toilet paper to his super and saying that these are my problems on the ship, I don't have this, I don't have that. I think that process of communication and access to knowledge, to solutions, is a lot faster now. And it's here where we come in with this little course, if I may say, or an interaction, or let me just call it a YBM show, all right? And here we are going to have two objectives, basically. These are to understand what are the advantages of being a naval architect and a marine engineer, and for having the knowledge, for the people who are going to sea. Number two, what are the advantages of being a naval architect and marine engineer as an all-purpose engineer? That let's say that someday you are not at this, not going to sea, and for all your compulsions in the family or otherwise, you have to find a job on the shore. And this is where we come in here with this module. And this first module is a trial that I'm doing, and hope we can find a way to carry it on into another level. And here I will also invite a lot of my other fellow alumni in different fields, the captains, the master mariners, people like that, and see how together we can create a better future for the future of shipping and for the marine engineers and cadets and the other seafarers on the deck side, anywhere, to find a little more meaning than saying, okay, I'm going on a job and I'll make that much of money and put this, and then I'll become a big man, I'll play golf and I'll retire. I'll have a lot of property. Well, all those things will come. Be certain on that. Those things will come. Happiness. It's the happiness that we all derive from what we do. And if there's no happiness, if there's no contentment, satisfaction from what we have done, then the life seems like a waste. And this is so two aspects, let me say. What are the advantages, firstly, to go to the sea? And then what are the advantages, what this knowledge can do if we have to go to some other place, So let's start with naval architecture and the ships, how they came into being. Now, start with the boats. We know that the Eskimos, the Red Indians, all ancient tribes have been like making boats. They are carrying their, they go fishing. They carry for the food, for the little transportation. The boats did come, and that comes from common sense. And this is what I have learned in my life, that a lot of naval architecture and ship construction and the marine engineering is about common sense. It also kind of reflects what a very knowledgeable civil engineer once told me when I asked him, when I was going new into the hydropower sector, and I said, "Hey, I don't know civil engineering, I am a marine engineer." He says, "What is civil engineering? It's just common sense. What do you do when you build a house? You tell him, okay, I need this kind of a room, I need this kind of a bathroom, I need so much space here, I need so much, this is my stairways, this is my entrance." You tell him. And what does he do? He just sketches it out, he lays it out for you, and here you have your house. And then he builds that house, he charges you money, you put somebody else, somebody who's constructing your house, you get him to work, you pay that guy, but still you're standing there and seeing that he's doing, and you are always the right person to tell him, this thing doesn't look right. These bricks are not of good quality. This mortar is not properly done. How do you do that? It's common sense. And that's what we'll use. We'll see what kind of common sense we are building from all the studies and all this experience that we have been gathering in life. So let's start with naval architecture. Now, what our man Archimedes did was, all he said was that the weight of water displaced is equal to the weight of the body that is going into it. That is the ass of Mr. Archimedes, Now, naval architecture is a study of townships. How does that sound? That's how I know it. When I went to the shipyard for the first time, and then I saw this Coast Guard ships in the US Navy being built. And of course, I've come from I had the privilege of having worked on the cargo ships, the bulk carriers, the tankers, and what have we. So when I went over there, then to actually build that for another purpose, it was like going from one perspective to the other. And that's what we do for naval architecture. Naval architecture is a whole lot of perspectives which are built around the desires of an owner to make money by putting ships into the water and getting a crew and getting clients and that's how we say that the people people who work on the ships carry the lifeline of trade. Naval architecture becomes a study of a floating township. That's how I would like to express it. We have the additional feature of propulsion that do this floating township. What do we have in a floating township? We have in a floating township urban infrastructure. We have on the ship an infrastructure which is the superstructure, which is where the accommodation lies, where we have all the galleys, the people, the accommodations, the alleyways and things like that. And then we have the hull. The hull carries sections where there's a section where the engines are located. There's a section where the cargo is going to be put. There's a section where the steering mechanism is going to be put. There's an area where some pumps and some other paraphernalia that goes into doing the actual work of the ship is going to be put. There are going to be cranes and there are going to be derricks which are going to carry the cargo from up there. There's going to be a lot of deck equipment. There's going to be a lot of appendages like, you have the ship's ladder, the bollards, the things where you tie the ropes. It's very much akin to civil infrastructure, and that's how I translated from naval architecture to to the power projects and doing hydropower. Civil is easy to learn if you can understand the mechanics of materials, which is your course in DMET or in any of the marine institutes. Then we have strengths and properties of materials. Then we have power, diesel, steam, gas turbines, water, wind. I started with the ships with the diesel engines. I worked as a consultant on the diesel engines in Africa, and then I've done gas turbines in a power plant in Virginia, USA, and then I have done wind power in the south of India with a company that I was working for, and of course I spent a lot of time in the hydropower sector. Whatever I learned in college, in DMET, was all I needed to do all of this. And all those examinations we sat when we were doing the marine engineering exams, the seconds ticket, the chief's ticket, and the study of naval architecture in the colleges. Then one of the large assets that a marine engineer gets is in the study of hydraulics. From hydraulics, I mean piping of whether the piping is for water, the piping is for steam, the piping is for oil, the pumping. What are the differences between pumping of water, pumping of oil, pumping of slurry, pumping of all these different chemicals? How does the properties of material changes? Everything we learn between the time that we have entered our marine institute and the time that we are on the ship and having spent and given our chief's examination, and then we carry on into the future examinations. And then one of the most important aspects, how does the ship get built? So the economics and the commerce of the ships. Shipping is a high capital and high investment business where we have to assess risk, and that's, as a consultant in the power sector, that's what we did, what I have done. I've been asked to do by the clients, by the customers of my ownerships with whom I worked, and then based on the risk comes costs, because the cost of a ship is also takes into consideration the risks that are going to come in, firstly in building it, then in putting it in water, and then later on the lifetime risks that are also going to come. Why? Because the ship is not just paid in one go. Every ship owner has taken a long-term loan from the banks, and based on the money that he's going to get and the money that he's going to spend on it, that is going to determine the success of the ship owner. And as such, that success will be translated to the shipping industry, and then finally to the benefits to this world, and where we say that our role is to maintain the lifeline of supply. Right now, guys, we are in Corona times, and I think this is an excellent time for us to get together here and take this time to ponder how this interaction is going to take place. When we say that we are engineers, we are firstly talking about the design, and based on the design, we are talking about the maintenance. It's not that the maintenance is coming first and then the design. When we are studying in the institutes, first we are being taught the design, and then because maintenance is going to be an automatic course of knowing about the design. So in design, we say that no ship can be totally safe in all the conditions. All that a designer has to do, can possibly do, humanly possible, is to assess what those conditions are. And in assessing those conditions, a designer has to be very well equipped to know the history of shipping. Every ship is built on what we have learned from the previous constructions. Just go into the psyche of an owner. What kind of a ship does this owner buy? The owner is a man with money. He is not a naval architect. He's not a marine engineer. He only wants to know what has worked before. So he takes benchmark of a ship which has existed. He says, hey man, I want a ship exactly like that. And I don't want any risk. Don't put anything else. Now when that is given, the parameters of the designers is already built in. There are two ways to do it. Either you just take the design of a ship and then just copy it, replace it. And what else will you do? Just like that civil engineer story I told you, just like that, you tell them, okay, my accommodation, I want this crew to be like this. I'm going to pay this crew, because the kind of accommodation you give will be the kind of benefits that you're going to give to the crew. You want to give the crew more, or you want to keep the cargo more. Always these kind of trade-offs are going to be there. So you've made your mind. I said, this is the kind of thing. Okay, my accommodation is this, and I want this space. The maximum space people want is to carry the cargo, because that's the purpose of the ship. Now, to mitigate risk, whatever are the risks that the owner and his team of engineers, because owners have a team of engineers who tell them, man, this is the risk. So whatever the risk you have counted on, the designer's job is to exceed the design considerations than those risks. The engineer, which means the engineer has to tell from his side that there are going to be more risks, and this is what it is. Or basically, all that risk has been already built into the designs of ships, or of the power plants, or whatever else we do, the machines that we build in life, in any other field of work. Then the process of design excellence, that's what makes the process of design excellence historical, and an evolution of several good designs which have been done before. And then we all know the story of the Titanic, and I don't need to repeat, you all know it, what the story of Titanic did for shipping in the earlier part of the 20th century, and how this field of naval architecture and marine and the safety of life at sea, that is SOLAS, came into being. So it's a science derived from historic fact collection and evolution of formulae and thumb rules. Thumb rule is a very important aspect of naval architecture. It's that kind of instincts that we build over a lifetime that makes us good designers. Just knowing about the formulae, the things is not sufficient. And that's why this course, or this module, or this show, the YBM show as I'm calling it for now, is about interacting with other marine personnel and getting their views and what their thoughts are, so that the cadets, the future ship engineers, the existing ship engineers can make their own lives easier and better. And also, when you study those examinations, if you are interested, if you find excitement and passion in that study, then you learn better, you perform better in those examinations. So this will be my endeavor to make you interested and a little passionate about design and engineering of marine engineering and naval architecture. What is the essential difference between working, when you all go for a job and then you're saying that this is a good company and this is a bad company? What is the difference between a good company working for a good company and working for a bad company? A good owner factors more things as his responsibility into running his ships. A bad ship owner factors less things. And that's what makes the shipping industry and the trade industry very complicated. We are all here to make money. Everybody is here to make money. And what are you as an engineer? You are the man stuck in between. And that's where our tensions, all our problems in life come. All the problems that I've faced, you have faced, my friends have faced, all come from this being sandwiched between the owners and the clients. And we will prepare you for that. And what they say in business, making balls of steel. Yeah, we'll try to do that. So balls of steel comes when we are very good in safety aspects. And I think 80% of your training too is built around learning about safety. And when we talk about safety, we talk about the fire, we talk about life-saving equipment, we talk about oil spillages, how not to do them, how to get around them, the study of environment, then about evacuation, where the ships are, when everything is gone, and you just have to jump out of the ship. you know, the equipment that goes into that. That brings us to the rules and regulations. So I'll come back to Mr. Archimedes. What did Mr. Archimedes do that would not have happened if he was not there? The ship, in all likelihood, would still have come. Let's say if Mr. Archimedes was not there. But what happened with Mr. Archimedes on one side and the 20th century Titanic on the other side is a certain thing on how much to load the ship. And when we talk about buoyancy, when we talk about the dead weight, when we talk about the ship, the load lines, what has come about is the rules on how much to load. And I think most of the work that goes of people who have graduated from the ships to becoming supers or administrators in the shipping companies is how to keep that load line factor, because the load line is what determines profit to the owner. It's not just one of those things you put for your exam, that L-shaped thing with those lines. Somebody is determining them. Then as the ship is growing old, somebody is certifying your ship whether it still adheres to that. And how does that happen? As the ship starts getting old, its body starts rotting. It's just like the man getting old. It cannot carry the same weight, isn't it? So it will carry less weight. And that is why the ships have to keep going through classification. They have to keep going through changes. There will be repairs, there will be modifications, there will be even change or replacement of machinery and equipment. To the whole dynamics of ship design, right from the hull itself to the different machinery and all, are all entwined into producing the result, which was as a certain percentage of the original ship, which means what is the efficiency of your ship's materials and its machinery as compared to the original. And that is why the load lines keep changing as the ship gets old. Your certification keeps getting changing. And this study is not complete until you understand naval architecture. Then we come to the responsibilities of carrying all different kinds of cargo. The refrigerated cargo has a different kind of responsibility. The carrying dangerous and hazardous cargo, chemicals on the ships, need another kind of safeties. All these ideas ultimately get translated to handling things at shore, and that's how you get your shore job. If you have become very good at whatever kind of ship that you worked on, you are in every likelihood going to be a success in any other job outside of the ship. There's a problem. The problem is, does the other side know? The other side doesn't know. And this is another objective. At the end of this course, I'm going to put all these objectives as a list so that they're there for you after we have finished this thing. All these are the objectives of this show or this module that we are going to give you, that how do we start projecting or prophesizing how our life is going to be. When we can prophesize, we have a control over it. Let's come to communication. We are in days of social media. When we are saying a lot of things, but we don't talk about betterment within our circles. And I have been on this very wonderful email forum that we have called 22 Knots. And this gives me a lot of insight into how the marine engineering field, the shipping fraternity at large, is going and how it's proceeding, what are the challenges. So even though I'm not in this field, I still continue, and I think most of us do, because once a sailor, they say always a sailor. It's something in the sea air, once you have imbibed that, once you have kind of sniffed that, things won't change. And that's why we always want to do better for the shipping industry, no matter where we are. if we keep doing that, the experienced people keep doing that, they don't go to sleep and say, I've earned a lot of money. And then the future disasters, the future frustrations of people on board ships, people in the offices on the ships, the owners themselves, because the owners themselves are in a big soup right now, as you say. There's been piracy on one hand, now there's coronavirus, and it's going to affect trade. There are all these kind of trade fights, trade wars between the companies. The economies are going up and down. This is very hard. It's very volatile. It's very hard to predict what is going to happen next. We have to all appreciate one another. So that becomes one more objective in this list of what we are going to try and do. Some of you here who are listening, the seniors, will be clients now, and this is be also kind of an appreciation course when you're sitting on this other side as the clients. And in essence, what we want to achieve from the show, number one, a reminder of reasons why we came here in the first place. We came for money. Okay, we got it. What do we do from here on? What we have taken as our pluses. When we tell the youngsters about the pluses, it excites them. Then we also have to tell them about the minuses. I was at one institute in Africa, and they said, no, don't tell them about the minuses. They will get scared. It's not a matter of being scared. You're not going on a ship to get scared. You are going there so that the others around you don't get scared. You are the engineer. You are the master. So how can we hedge against the minuses for the future? I think this is what we want to bring out as well. And this, I'll try to get more people from the alumni in the other fields, and maybe they can come and hit on the reasons a little better. Another thing we have been discussing a lot on these forums is the technology needs. I really want to use some of the libraries in the various institutes, the Tolani and the IMU, and I see they're having some of these new books which are come. We'll try to give some an insight into all these different books, a little book review, let's say, on how you can benefit from a particular